In individual 1, a chromosome experiences pericentric inversion, so the sequence of the genes, including the centromere, do not align properly between the two chromosomes. But the formation of an inversion loop can help. An inversion loop can be seen as a racetrack for cars, where each chromosome is a separate track, and each track has 2 lanes. The top track is a normal chromosome, and the chromosome with pericentric inversion is a looped track beneath it. The loci within each chromosome can be seen as checkpoints on each road, and the centromere can be seen as a pit stop. The loci present in both chromosomes are M, I, J, centromere, K, L, H, G. Note that the loop on the bottom road is set up so the checkpoints I through L appear in the opposite order. If there is a crossover between J and K, 2 of the 4 lanes will merge onto a different lane between the 2 checkpoints. Now let's watch the race. With 1 car per lane, the route and checkpoints crossed by each car will represent one of the 4 gamete products. The red car goes first, along the lane that matches the normal sequence of checkpoints. No inversions or merging, and it passes through each checkpoint once. The green car is in the lane that matches the sequence of the looped lane. There is an inversion of checkpoint sequences between I and L, but no merging. It also passes through each checkpoint once. The blue car drives through the lanes where it merges between checkpoints J and I and misses the last 2 checkpoints to return to checkpoint M. The purple car will approach checkpoint K from the opposite end and merge at the crossover point, so it repeats checkpoint G and H and misses checkpoint M. Looking at the gametes, we know that the red and the green cars are viable because they passed all checkpoints once. The blue and purple cars were the merging lanes, so they missed and repeated checkpoints. Repeating or not passing checkpoints disqualifies them from the race because each checkpoint must be crossed once for the outcome of a fair race, just like how all gametes are needed once to produce a non-recombinant gamete. For the second individual, there will be no loop in the racetrack since there is no inversion. There is crossover, but due to absence of inversion, it will make no change in the sequence of the checkpoints. All 4 products will have the same sequence of checkpoints with no occurrences of checkpoint repetition or bypassing. This means that none of the cars are disqualified since each car passes all checkpoints once for a fair race. So for individual 2, all of the resulting chromatids will be the same and will be viable.